In this lecture, we will talk about use matrices to solve the system. You see here we have x plus 6y plus z equals 0, x plus 2y minus 3z equals 0, and x minus 3y minus 8z equals 0. So you can see here all constants are 0. Okay? And here we have a note. All constants are 0, then the system like this is called homogeneous system. Okay? If all of them are 0 here, then the system will be called homogeneous system. Okay? And if you take all the coefficients out here, you see x is actually 1 times x for all of them. So you may put 1, 1, 1 here. And then 6, 2, negative 3, 6, 2, negative 3, and 1, negative 3, negative 8, and 0, 0, 0 here. We know if you include the constant column, then this system will be called augmented matrix. This matrix will be called augmented matrix. Sometimes, we like only to take the coefficients out of the system. This might be the case because the rest of them are 0. Okay? If you only take the coefficients out without including the column of constants, then this matrix will be called coefficient matrix. Let's still right here include our last column, constant column right here. So let's work on the augmented matrix. Step 1 we want to use is, in step 1 we want to make this place the first element in the second row and the first element in the third row be 0. We basically eliminate x's down here first. So if here is 1, we need the first row, we need a negative 1. And then negative 1, positive 1 can cancel each other. So we use negative 1 to times the first row. What do we get? 1 times negative 1 is negative 1. 1 times positive 6 is negative 6. 1 times negative 1 is negative 1. And 1 times 0, negative 1 times 0 is 0. Okay. Yeah. So basically we use negative 1 times every element. And negative 1 times 0, we get 0. Then we add onto the row 2. 0, negative 1 plus 1 is 0 here. Negative 6 plus 2 is negative 4. Negative 1 plus negative 3 is negative 4. Okay, negative 1 plus negative 3 is negative 4. And 0 plus 0 is 0. Okay. Alright. So this is the operation. The first row times negative 1 add onto the second row, give to the second row. And here, since this is also positive 1, we can also add this negative 1 on that. So that means we can also use negative 1 times row 1 plus row 3, give to row 3. So here is negative 1 plus positive 1, you got 0. Negative 6 plus negative 3, we have negative 9. And negative 1 plus negative 8, we have negative 9. 0 plus 0 is 0. So, this is the actual operation, elementary operation, we did on row 2 and row 3. Alright. Now, those two places are 0 now. And then we need to make this place be 0. Before we do that, we have observed here is negative 4, here is negative 4, here is negative 9, here is negative 9. We like to make this place be 1. So, row 2 divided by negative 4, or you may say row 2 multiplied by negative 1/4. Then we got new row 2. You see, negative 4, 0 divided by negative 4 is 0. Negative 4 divided by negative 4 is positive 1. Negative 4 divided by negative 4 is positive 1. 0 divided by negative 4 is 0. Row 3, that's 0 divided by negative 9 is 0. Negative 9 divided by negative 9 is positive 1. And then negative 9 divided by negative 9 here is also positive 1. 0 divided by negative 9 is 0. Now you know, in order to eliminate this 1, upstairs needs to be negative 1. This place. So this row multiplied by negative 1. 0 times negative 1 is 0. 1 times negative 1 is negative 1. And 1 times negative 1 is negative 1. 0 times negative 1 is 0. Now we have a 0, negative 1, negative 1, 0. Add on that, then you can cancel. 0 plus 0 is 0. Okay. Negative 1 plus positive 1, you got 0. And negative 1 plus positive 1, you got 0 again. 0 plus 0 is 0. So basically, in this case, row 3 all are zeros. Okay. And we didn't do anything with row 1, so we keep it. And we didn't do anything with row 2, we still keep it. Now, this is the echelon form now. Okay? Echelon form. For the echelon form, what you want to do, you then convert this back to the corresponding equation to do the back substitution. Okay, 0 times x, 0 times y, 0 times z, that's z. So basically, you don't need to write row 3. 1 times y is y. Okay. And then 1 times z is z. Okay, 1 times y is y, 1 times z is z. 1 times x is x, 6 times y is 6y, and 1 times z is z. Okay. Now, here we have 2 equations, 3 variables, x, y, z. We let the last one, z, be c, means a constant, can be any constant. Okay? You can let z be 3, you can let z be 5. You all get all different solutions. Okay? So let's say z is a constant c. Now we all have our first equation, we have x plus 6y plus c, because z can be any constant. Okay. We also have a y plus z. Now since z is c, so y plus z. Minus c on both sides for the first equation and the second equation. So you may cancel this positive negative c. Then the left will be x plus 6y right here. Right hand side is just negative c. Minus c on both sides for the second equation, you cancel positive negative c. So y is the only term on the left. Right hand side, 0 minus c is negative c. Now look, y is negative c. You may do the back substitution, put this negative c inside. That would be 6 times negative c, because y is negative c now. Okay, so 6 times negative c is right here. X, you copy it, equals negative c. Now, 6 times negative c is negative 6c. Okay, and then what we have is both sides add on positive 6c, so you can cancel positive negative. And then you cancel this positive negative. So on the left is just x. On the right, 6 minus 1c. Okay, so 6 minus 1 is 5, and c right here. So x is 5c, y is negative c, and z is c. So we have the solution now. Of course, again, if c is 3, then z will be 3, y will be negative 3, and then 3 times 5 is 15, x will be 15. Okay. Of course, you can let c be 1. If c is 1, z will be 1, and y will be negative 1, x will be 5. So this equation has infinitely many solutions. Okay. Okay, that's the first example. Homogeneous system. We introduced c right here to express this equation has infinitely many solutions. Okay, of course, you can let c be 0. If c is 0, z is 0. Negative 0 is 0, so y is 0. 5 times 0 is 0, so x is 0. So x, y, z all are zeros. If you plug in here, 0, 0, 0. So 0 plus 6 times 0 plus 0 is 0. 0 plus 2, 0, minus 3, 0 is 0. 0 minus 3 times 0 minus 3 times 0 is 0. Okay, 0, 0, 0 for x, y, z. This set is a trivial solution. Okay, but we can find out many other solutions other than zeros.